Data structure in Java continued. Program code of push operation. Let us look at the steps of how to perform push in a stack. As explained in the previous video, the new element has to be connected to the place where the starting point is. Now, in this picture, you can see there are current nodes till this much. So, till start, I can see there are elements. From here, I would have got the element for the list. Now I am going to add 250, which is in a node. I have named that node ins. Ins is the name of a node, just a name. There the data is and its address is null. Now can you think how the connection can be established? Well, the code says that ins data gets the value which is val. Just ins has got its memory allocation done. Some internal memory has been allocated to ins. Now ins's next part is given whatever start is. This is what is meant by putting start's value in ins's next. That means now ins will know where the next data is, and therefore now I can remove start from where it is and bring it over to wherever ins is, which is to remove start from where it was, which is start is losing its current value and getting a new value which is present in ins. So can you understand? Here start is moving over to ins, and then when this will go back, when this start will get returned, do you think it will hold the same value as it started with? It started with D5, but now it's going back with K8. Now in this way, I can keep on adding one more ins and one more ins, because every time I call push in stack, a new ins is getting created. Well, so let me show the program also to you. Then this part I'll call the program portion, the code portion of what is the meaning of putting, calling the function push in stack, right? Well, give a look at make stack this time. There are changes that I have made in make stack. The previous make stack was doing everything inside this method only, but this time I am utilizing push in stack, and see how push in stack is pushing ELE every time in the current existing list which started with the node start. Well, now I should run the code. You can pause the video, look at the code carefully, and then I can run, and I'll show you that this is also doing the same work as the previous make stack method was working like. Well, this is the program to be executed. Okay, display is there, make stack is there, and make stack is utilizing push in stack. Well, I'll call main. Main will call work on stack. This work on stack is this statement. The first data, I entered the first data is 101. I enter the next data. You see this next data is getting entered in ELE, not directly in any node. This ELE is going to enter. So I'll show you where is this going in. Press 1 to enter more data. Now where did ELE go? ELE went here. Then start equal to push in stack. ELE is 101. Start is coming back. Now after start has come back, press 1 to enter is this one. Okay, I press 1 and I enter. Enter the next data. After 202, let me enter 303. Let me enter one more data, and I will not go any further, and then I will show you what will the output. Press any more data? Okay, I don't want to enter any more data. So the present list is, it is in reverse order. Can you see the last element is getting accessed first? That means this start had worked the way it was expected. That is why it was going on adding, adding, adding. Now your turn to pause the video and go over it all over again, and then just see how the flow is making the stack. Okay.